Yeah.
Hey, hi, good morning.
Morning.
Good morning, Danny. Welcome, welcome, everyone. Welcome, everyone. Give me a second. Was getting a bit overloaded. Welcome, everyone. Let me just stand because I've been sitting for a while. So, welcome. Hurts my back to sit too much. Older people problems. But yeah, welcome everyone to pre-calculus here this morning. Hope y'all are doing okay. Um, just making sure I'm letting everyone. All right, let's jump into our check-in question. I know some kind of already seen it, but it's okay. Maybe more time to think. Okay, our check-in question today is okay, it's hold on a second. Also, make sure that we're in. Yeah, okay. I thought I saw someone that wasn't in this class. Okay, what games do you play for fun? By games, I mean like card games, any video games, board games, any games that you do for fun. You know, it could be during whatever quarantine. So I know a lot of students like Uno. That used to be a thing. I think it still is for those who are in person. Um, welcome, welcomes. Cool. I'll let y'all go ahead and answer that check-in question as I'm double checking who we're missing here.
I'm
Um,
gonna just say it right now.
okay.
Cards Against Humanity is like the greatest game of all time.
Oh my gosh. Yeah, I played that before. I played that during I think it was like 2 years ago at a senior picnic. So it was like the last, the senior picnic last day with the teachers back 2 years ago and it got crazy. So I know what you're talking about. I was just like,
My first
"Whoa."
time, my first time playing it was when I went to Columbia with
Uh-huh.
like the students from here,
Mhm.
and I swear to God, I made everybody on that trip crack laughs. You can ask Miss Clark, you can ask Mr. Garcia, you can ask Miss Rayvon,
Oh my
you
gosh.
can ask whoever went on that trip
That sounds really, really fun.
with that game.
Right. That sounds really fun. Yeah. You could get quite a few laughs, but I I bet that was super fun for y'all. Wow. Awesome. Let's go ahead and see what's in the chat. Let's see. All right, we got, yep, we got the Cards Against Humanity poker. Okay. Someone knows how to play poker? I don't, but Fortnite. We got Fortnite's like a video game, right? And then Call of Duty, and we got Uno, Texas Hold'em. Never played that one. Pokemon, the Pokemon cards, is that or is that a game? But at the moment, I'm so it might be a Pokemon game then. I'm upset.
It's both,
Okay.
but yeah.
Wow. When I was in elementary school, Pokemon cards used to be the thing, and people would have binders full of Pokemon cards, and then they banned it because then it got stolen. I don't know. It was wild. A lot of memories with the Pokemon cards. All right, Uno, Dominoes. That's been a while since I played Dominoes. I don't know what MC is. I haven't played any games like that. Whoops, recently. I don't know why the thing keeps switching. That's okay. Me neither. I haven't really played much. Buzzed, LOL. Don't know what that game is. We got Uno, Pokemon, Minecraft, and then Uno goes crazy. Yeah, it does. Though I never understood it, but then again, I need to sit down and actually play it. We got Monopoly, Uno, BS, Minecraft, Cards Against Humanity. Another someone likes that card game too. Rubit, don't know what that is. Warzone, Apex Legend, don't know those. So those are a bunch of things I should probably get into. We got soccer and basketball. Yeah, like the real soccer and basketball, right? All right. All right, let me go ahead and see who we're missing, and y'all can double check and confirm with me. We got Cold War and 2K GTA. A lot. I don't know what that is. Sounds like a video game. Yep, yep. We got Rob here. We got Subs. Okay, so this is what I'm missing. Please correct me if I'm wrong because I did this super fast. I was too into the games y'all were mentioning, so my bad. But Denise, I'm missing Denise. Miles Ford, are you here, Miles? Let's see. Yeah, I'm missing Miles Ford. I'm also missing Gyrel. Yep, missing Gyrel as well. And Sincere and Celia. So that's who I'm missing. If you're friends with any of these folks, please let them know. Send them a text to come on here into pre-calculus. Let's get some credit today. We always have some in-class credit, so that's not always just, asynchronous work. Let me go ahead and hit submit. All right, y'all, thank you so much for that check-in. Now I got some ideas of what, games to play here with family at home and all that. That's cool. And or playing some basketball or soccer real time. All right, let's jump into our agenda. So we just had our little quick attendance check there with sharing of games. We're gonna wrap up what we started last week, Thursday. So last week Thursday is where we left off, and it's Tuesday now. So it's like 4 days. It's been a while. So we're gonna wrap it up. We're gonna review and refresh ourselves. And then we're going to talk about how limits kind of connect to tables. So remember, our focus has been limits so far. I do not know if we're going to get into the group practice. If we do, right? But we'll see. Maybe you'll get started in the groups, but then we won't finish until the next class. So next thing, async 1 and async 2 were graded. So I did not do grading this morning. So if you did submit something, do let me know and remind so I could check it. Again, we are just beginning. So like there's just three asyncs up. So there's definitely time to catch up. It should be like the time to be okay with it. You don't want this to pile up. So asynchronous number 3 barely posted. This one is due tomorrow. So don't feel overwhelmed. You could still totally make up the stuff. Just let me know once you do it so that you're not, letting it all pile up. Let me know if anyone has questions about that though. And then for Rob, let me make sure I make you co-host. There you go. All right. Cool. If there's no questions, let's get started. Also, y'all, remember, when we're taking notes in this class, remember how it goes? What you do is you go to our Google Classroom and you make a copy of the daily notes. Today is day 4. So we're day 4, quarter 3. You're just going to click right here and it should take you to today's notes. So let me give you all some time to go ahead and join me here as we're jumping back into it. And we're going to be starting from slide 4 and kind of reviewing from there. Great. Yay, we see someone there following along with us. Give you all a second to go ahead and open up your own slides. Yay. We're getting more and more of you joining in. Thank you for being here, y'all. So I think we're just missing Sincere and Celia at this moment. Welcome, welcome, y'all. Again, make right now what we're doing is trying to go to Google Classroom, open up your own copy of the slides to follow along with me, make some annotations. Yes, make a copy because then otherwise you won't be able to annotate on it if you need to. No problem. Welcome, Miles. Yeah, I updated the attendance. No problem, y'all. Yes, make a copy of the slides. Of the slides. Name of the slides is quarter 3, day 4. Quarter 3, thank you. Day 4. There we go. Yeah, no problem. So I'll let y'all get to this slide deck. Whoops. Awesome. A good bunch of us are there. Again, usually it gets posted right here on Google Classroom. I try to keep this at the very top, and your asynchronous are right there at the bottom. All right, cool. Great. I see a few of us are making their copies there. All right, y'all. So we're going to go back into what the big ideas were. Like I felt like on Thursday this got kind of rushed at the end. So we're gonna again talk about what was happening when y'all did this in a group. Um or actually this was not in a group. Wasn't this individual? I think this was individual. And yeah, this was individual. This was not a group. So this was an individual exploration we did. If y'all remember that. Individual, that's the one where I was giving y'all feedback on how to create the limit notation, and then y'all were making some changes. Remember that? That's what we did last time. So big ideas. The big ideas were that in this case, in this picture, Bertha and Benny, they met up at the same point, and the point was y equals 2. So how we were able to write this is, let's see. So coming in from the left, I believe was Bertha. So we could say this is Bertha's movement. As x approaches 3 from the left, her limit, she ended up at 2. And then for Benny coming in this way, he starts on the right-hand side of the graph. So he has a plus after the 3 because he's starting on the right-hand side. And he also ended up at the y value of 2. Now, what do I mean by right and left-hand side? If you remember what that is if you draw a line down through where they're supposed to meet, and if you label your graph like such, like this is my left side of the graph, and this is my right side of the graph. Because Benny's coming in from the right or starting on the right hand side, that's why he had a plus right here. And this is Bertha. Because Bertha is starting on the left of the line here, she has a minus. And this is where they ended up, their height. And they both kind of ended up at the same location, a y value of 2. Now, when this happens, this is really important. So this was a huge, big idea. When the left and the right-hand limit are equal, when they're equal, and what we mean by equal is that their y values, they meet up basically the bugs. When they're equal, we can write the limit without these plus or minus signs right after the number. We can write it simply like this. Whoops. Notice how that works. So because both of the bugs are going to end up at the same location, we just say that the limit of my function as x approaches 3 is just going to be equal to 2. Now this means that this limit only works when it's coming in from both sides and they both meet up the bugs. Let's see what's in the chat. Yeah, so Danny says, since it's a recap, we don't have to write the notes down, right? No, that's totally up to you. So again, when you make a copy of your own notes, it's totally up to you. So yes, we talked about this, right? And what I'd like you all to do right now, let me go ahead and clear this. So yes, this is a recap. Let me clear my screen here very quick. What I'd like you to do is to refresh yourselves on what we wrote on the Padlet, which is kind of down here. For those on the slides, it's in our notes section of the slide down here. I'm also going to paste it into the chat. So I'd like you to review the working Padlet that we're on. Click on it, and once you click on it, you should get to here and take a look at the column 6. What did y'all think when we talked about this last Thursday? Y'all can scroll through and see the synthesis of the big idea, like what y'all were saying about it. And the question was, when can you drop the plus or minus sign in a limit expression? So, and again, that's basically what's happening here. These two bugs met up, and because they ended up at the same y value, we were able to drop the plus or minus notation. But again, take some time to review what you wrote. Take some time to take a look at your what other students wrote. Then I could just pick out a few responses here that kind of stand out. Some of you didn't finish though. You want to make sure you finish up your comment for your credit. And a lot of you had these ideas that when the limits are equal, that's when you know, like down here, that you can drop those plus or minus signs. Again, when the left and right limit are equal. So specifically, this answer is mentioning left and right, because you can drop the plus minus sign when both the limits are equal, same y and x value. This one's more specific there. Okay, I like this, Miles. Oh, sorry, let me not call it names, but you could put the plus or minus on the bottom when the limit is coming in for the right and the minus when it's coming in for the left. Yeah, so when you're specifically left and right, you can put those signs there. And I did want to point out one more right here. RG says you can only put a minus or plus sign when the left and the right side are not equal. I like this view. It's very interested to see the interpretation in this way. This is also a correct interpretation. But yes, we can drop the plus or minus signs when the limits are equal. In other words, when the bugs meet up, they end up meeting up the same location. And then some of you did do this part right here, which is awesome. Some of you had put down what made sense and what didn't. So y'all can review what made sense to y'all or what didn't. This is just reviewing right now. Right now, we're not typing, you are just reviewing this. And we're gonna jump back into the slides. And in your slides, as we jump back, remember I showed you all the video from the Mean Girls movie? The one where she answered, oh, the limit doesn't exist. We're gonna finally know what that is now. So we're gonna go ahead and make connections back to that movie. We're going to slide number 5, y'all. All right, so we took a look at an example right now from last week where the two bugs did meet up. So they got to meet up, have some tea, have some cookies, their brother and sister. But remember, there's sometimes cases where the two bugs don't meet up. And this is an example of such. And I believe this one was Benny up here, and down here was Bertha. And we have their corresponding limit expressions. What does it mean when the two bugs don't meet up? It's up here. So when the left and the right limit are not equal, see how 1 is equal to 1? One of the limit expressions is equal to 1, and the other one's equal to 5. That means they're not equal. The y values are not equal. What we say here is super important is that the limit does not exist. That is when the limit doesn't exist. This is super key. AKA, when our bugs don't meet up, is another way to think about it. Or think about it when the left hand limit is not equal to the right hand limit. How do we write that though? And how do we make connections to dropping the plus or minus sign? It's like so. So let's say I want to drop the minus and the plus sign and rewrite it as the limit as x approaches 3 of my function. For this specific case, because our bugs don't meet up, we say D and E. This means does not exist. Shorthand way to say it. Let me go ahead and write that in. Does not exist. So this one is a humongous big idea as well. So now we know when the limit does not exist. And it kind of makes you think about what connections you can make to what you saw in that movie clip. Yeah, we have LDE, wait, no, DNE, yep. Then we have typo. Okay, y'all, I'm trying to figure out how to shorthand the DNE. It should be. Okay, good. I am recording, just making sure. Cool. Let me pause here. Let's see. Does anyone have any questions? So this is when we could say a limit does not exist. And you can make connections to the movie, but if you all remember, back on if you look on the Padlet when y'all answered, when did she say that a limit does not exist? She said something that the limit doesn't approach anything or something like that was the answer according to her. But according to what we saw and what we're learning right now, it's when the left hand limit is not equal to the right hand limit. That's when we say a limit does not exist. So just reflect on that. And let's see if there's any questions. All right. And again, this is on our big ideas packet. So again, this one, you were asked to annotate the big ideas packet. That one is asynchronous number 2. So if you haven't done that yet, please get to doing that. I'll try to continue to bug some of you to get that in so that you get your learning in. So it's super important to take a look at the big ideas packet so that you can already start to create questions in your head on what makes sense, what doesn't, and what you need so that it can make sense to you. All right, y'all, let's transition into, oh yeah, here's a little re-emphasis again about when we could say D and E. Again, when they do not meet up, the bugs don't meet up, the left-hand limit is not equal to the right limit. This is when we could say the limit does not exist, D and E. It's just a shorthand way of saying that. All right, let's shift over to slide 6, which is now, let's go ahead and apply these big ideas into some actual problems, everybody. Let's apply this. And, maybe I might ask for y'all to share in the chat what you think, but let's do this. So here we have the limit as x approaches 3 from the right, the limit as x approaches 3 from the left, and then simply the limit as x approaches 3 when we drop the plus or minus signs. So remember before, we actually looked at this problem before, and then I told you guys, we don't know how to do this one yet. Now we should be able to know how to do it. Let's see. So the limit as x approaches 3 from the right. So remember, y'all, the strategy I like to do is in your mind mentally, or if you have a piece of paper and you want to copy this down, I like to draw the line down through the x value that we're interested in. I drew it down the x value of 3 because all of these are asking about 3, right? All of these are talking about 3. So I'm going to cut my graph in half exactly where the x value is 3. And I'm going to label that anything from the left of that line is left. Anything to the right of that line, we call right. Now, the limit as x approaches 3 from the right, the first problem right here, we're going to imagine, and let's just say this is Benny over here. Benny starting on the right-hand side, anywhere on the right. He could be over here. He could be this way. He could be much closer to the x value of 3. All we know is that Benny is going to try to move towards the x value of 3. And he's starting on the right-hand side. And he's going to stop once he hits that x value of 3. And then we got to see what height is Benny at once he stops there. Remember, Benny cannot fly, he cannot jump. He's going to end up somewhere. So here's my x value of 3. Benny's going to be right here. And let's see what's in the chat there. So Danny put 2. Yeah, looks like I drew Benny right here. And if I was to figure out what y value that is, it does indeed look like Benny ends up at the y value of 2. So 2, perfect. Now let's do the left-hand limit. So that's this one down here. Again, how that we would write that out. Oh, wow, I already did left and right. How we write that out is approaches 3 from the left. Let me just erase my little L and R since I already actually wrote those in. All right, so let's say Bertha is coming in from the left. So that means I can place Bertha on any part of the curve that's to the left of this line. So I'm just going to pretend Bertha's all the way down here. That means she's going to have to kind of climb up a hill. Either way, she's going to approach the x value of 3. She can't fly, she can't jump, and she's going to stop where the x value is 3. So she's right where Benny's at. Now, what y value is Bertha at? How high is Bertha? All right, we have another 2. This is from a direct message. And again, if you disagree, you want to let us know. The important part in math is asking questions, especially when you're unsure. Super important, but Bertha does indeed end up at the y value of 2. Take a look, she's going to end up right here. So y'all, cool. The right-hand limit, these two, change my color. Right-hand limit is equal to the left-hand limit. Now this is a big idea. When the right-hand limit is equal to the left-hand limit, what do we say about when we drop the plus or minus sign? What can we say about the limit? And then Daniel, you put 2 again. So you're saying that the limit is 2, and then Risha put it exists. Yes. So according to our big ideas, when the right-hand limit is equal to the left-hand limit, not only does it exist, but it's also going to be equal to 2, just like you said, Danny. So that is on point. The answer is 2, and yes, it exists. You could think of it as when the bugs meet up, your limit exists, and thus it's going to be equal to 2. So this is us applying those big ideas right here. Again, you could drop the plus or minus signs when the bugs meet up, and it will exist. The limit will indeed exist in this case. In a second, we'll take a look at an example where the bugs don't meet up and how do we apply our big ideas. Let's see if anyone has questions though on this one. Again, when you're making your annotations, you probably want to put in the answer as a comment because all of these are actually equal to 2. All right. If no one has any questions on this, let me go ahead and erase this work, clear my drawings, and let's do another example where we take a look at a graph that kind of looks broken apart like this one here. It kind of looks like 2 separate graphs. Oh, it already has the answers. Well, that's okay. We could go ahead and talk about it. So first off, how did we get 4 right here? I mean, I think it's nice to get the answers because then we could figure out, well, how's the answer 4? Step 1, these again are all approaching 3 first off. So I'm going to draw a vertical line down to where the x value is 3. Then we go ahead and we label the left-hand side and the right-hand side. Coming in from the left, that means I could place my bug, if you want to imagine a bug, anywhere on this left-hand curve. So we place a bug right here, and this bug is going to walk and it's going to stop when it reaches the x value of 3. So it's kind of going to go down and then it's going to go up right here. So this bug right here, which we could just say is Bertha, let's just say Bertha's always coming in from the left. She ends up right here, and that is indeed equal to a y value of 4 right here. So checkmate on that. Likewise, we could go ahead and check why is it that the limit as x approaches 3 from the right going to give me -3. So approaches 3 from the right is the meaning that this has. Well, again, you could go ahead and draw your bugs. As you can see, the only thing to the right-hand side of this line is going to be this curve that looks like this. It's kind of like an upside down parabola. We can imagine that Benny's over here, and he has very long legs, and he's probably like a spider. Anyways, he can't fly, can't jump. They just say, yeah, somehow this Benny has long legs. But anyways, he's gonna walk a little bit uphill and he's gonna go down. And again, he's also gonna stop at the x value of 3. And he's gonna end up right here. And this point is directly at the y value of -3. And that's how we get -3 right here. All right, now why is it that the limit as x approaches 3, dropping the plus or minus sign, is going to give us d and e? So let's see if anyone knows in the chat. Like, how do we apply this to our big ideas? Why is the limit as x approaches 3 without the plus or minus going to give us d and e, which means does not exist? Okay, so Danny put they're not equal. So specifically, when we say they're not equal, you're talking about the left-hand limit and the right-hand limit, right? These two?
Yeah.
All right, so that's right. So left-hand limit is not equal to right-hand limit. Therefore, the limit without plus or minus is DNE, does not exist. Again, another way you could think of it is the bugs are gonna not end up meeting in this case scenario. We're gonna have Bertha up here and Benny down here. They're not gonna end up meeting in this case. Therefore, we're gonna say that the limit without the plus or minus will be DNE, does not exist. All right, let's see if anyone has questions so far after we applied our big ideas here in example 2. So that was a D&E example. Cool, I'll leave this up in case anyone needs to like copy down a comment or anything like that, or add something, take a screenshot if you'd like of the notes I did here. If you're able to add that into your own copy, that's cool too. But again, questions totally welcome at this point. All right, awesome. I'm gonna go ahead and clear this up. And now we're gonna jump into the next line of business, which was our next thing. So again, I don't know if we're gonna get to the group work. That's okay. All right, y'all, let's go ahead and transition from limits not existing. Now we're gonna talk about tables. And here's two questions I'd like you to think about. These are essential questions to just think about. And we're on slide number 8, just for those following along here. So the essential questions that I'd like you to think about is how can we use a table to determine a limit? What I mean by table is like a XY table and a like input output table. Some of you think of it as a T chart, whatever you like to think of it. But looking at an actual table, how do we use that to determine a limit? Let's say you don't have a graph, but you just have a table. You don't want to plot all those points. How would you use a table and try to figure out a limit? The next thing I'd like you to think about is how can we make connections between tables and graphs? Like, what connections are there between them when it comes to determining a limit? Those are some two things to think about. Make sure you pause, read this for yourself, think about it a bit before we jump into it. All right. Now we went ahead and at least are thinking a little bit about like, what does this mean? Or what do you mean about table? How are we using that to determine a limit? Well, let's go ahead and jump into this. So before we get started, I do want to give a little bit of a brief talk about something that happens in graph that you've seen already, open holes, or for those of you who did the Khan Academy practice, you saw graphs that had asymptotes. Let me show you what I mean. So of course, we've seen the open hole. We've seen the bugs walk over these open holes and they haven't been able to fall in. Um, but what is a hole? So down here it says a hole in your function represents typo represents a point that is undefined. So that's all a hole means. It just means your function isn't defined there. But that doesn't mean that the limit doesn't exist because we all seen it does because the bugs are able to walk right on top of it and they're still able to meet. So just make that distinction. Now, another thing you might see is something called an asymptote. Usually, we draw an imaginary dotted line to represent an asymptote. On Khan Academy, I don't know if they do that or not, though. Sometimes the function just goes like up really fast. But usually, we do draw an imaginary dotted line so that you can see that there's an asymptote. What is an asymptote? So an asymptote represents an imaginary line that a function approaches at infinity. So what that means is that this function is just going to keep continuing to approach this imaginary line, but it's never going to touch it. Likewise, down here on this side of the function, it's going to approach it down in the negative direction, never going to touch it. It's just going to go like that forever, just getting closer and closer to that line. So those are just the two different things that can happen, and it's just important for y'all to know this, uh, so that we understand why we sometimes might need tables to kind of help us figure out a limit when it might be a little bit tricky in a graph. So let me give you all some time to take a look at this, time for some questions, and then we'll jump into the next slide. Right. Cool. So these again are just some definitions to know, or just some important, it's not really definitions, important function behaviors that you should just be aware of when it comes up. Because it might come up that you're trying to find a limit of something that looks funky like this. Okay, but what does this even have to do with limits? So up here in the blue, you could see here. So limits help us determine function behavior near a point, not at the point. So what I mean by that is, remember how we didn't really care whether the bugs ended up on an open circle? Because limits basically tell us how the function behaves near the point, very, very near the point, but not exactly at the point. Limits don't really care about an open hole. So that's just something to think about. So again, if I was to find a limit to this, it would look slightly different. Like some of you saw some interesting things once you went to Khan Academy and did functions that look like this. But we don't have to delve into that right now. But just so you know, this is key here. Again, limits don't really care exactly what happens at the point. It cares what's happening very, very, very close to the point. Okay, y'all. So I'm bringing back Benny and Bertha, the original problem we actually looked at. This was the same old problem. I'm bringing this back. And what I have for you here is the two tables. So this was Benny, this is Bertha. This was Bertha's limit motion right here. She was coming in from the left. And this is Benny's limit motion. He was coming in from the right. Remember, they ended up at different y values and they ended up not meeting for their t. And what I have for you here is I went on Desmos and I made a table for Bertha's movement. She started at around the x value of -2, and this was her y value location. She was down here in the negatives. And as she was walking closer and closer to the point of 3, she ended up at the y value of 1, which makes sense right here in the limit notation. So go ahead and take a look at that, and then we'll take a look at Benny's in a second. But just make some connections and also take a look at why I'm kind of like Bertha looks like she's moving faster here, but as I'm coming into 3, I'm getting in really, really close to 3. So we have 2.5. 2.9 is pretty close to 3. 2.99 is even closer to 3. 2.999, even closer. And once I hit 3, we get at 1. Notice how the y is behaving. Just some things to notice right now. And then in your mind, maybe make some connections between what you're seeing here. So that is Bertha's movement. And then we have Benny's, right? So this was Benny's limit. This is his motion, and this is his table. Take a look at his table. So again, he started at around x value of 7, and he started to approach the x value of 3 from the right-hand side. But because he's coming in from the right, that means he's going from 3.5 to 3.1 to 3.001. So I'm just getting really, really close to 3. But then once I hit 3, y'all see this? It's undefined. It's because of that open circle. So if I was to plug in 3 into my function, I would get undefined because the open circle. But even if the point is undefined, I still know that my limit will exist and that Benny will still end up at 5. What connections can we make to what's happening in his table? Notice how I don't really care what's happening here when it comes to limits. I don't care. What I do care is what the function is doing as I get really, really close to 3. The limit is still approaching 5. Notice how these numbers are slowly approaching, actually quickly approaching 5, because 4.9988, that's really close to 5. And this one's even closer to 5, 4.999 infinite nines. The limit is still going to approach to 5 for Benny's case. And we don't really care what's happening at 3. Again, the limit doesn't care what's happening at the point. It matters what's happening really, really close to the point. So that is like huge, huge distinction. Let me go ahead and show you these bullets again to kind of re-emphasize what I just said. So again, when it comes to limits, it doesn't matter what happens at the point, such as when you have an undefined value. But what really happens close to the point, Benny is still approaching the y value of 5, even if the point itself is undefined. That's important. Because our functions can have undefined points or even asymptotes, it's important that when we investigate limits using a table, we make sure that our tables are getting really, really close, or you could use infinitely close to the x value of the limit. So that's why I'm doing this. That's why these points starting to get really, really close to 3, because I'm trying to investigate what's happening around 3, not at 3. Likewise over here, I was getting really, really, I think I did a better job on this table. I took my time getting really, really close to 3, noticing that the limit was still indeed approaching 1. I actually didn't even have to look at this to make the prediction that this was going to be 1. The y value is approaching 1. So yeah, definitely. So this one's huge. Take your time. This is something that we're going to continue to work on, making connections with limits and tables. And it's going to be the thing that we'll be doing some group work on. So first, let this sink in. And then we're going to have a Padlet check-in a second. Let's see if anyone has questions on this part. And make sure you read the little bullet points there at the bottom. It's kind of synthesizing what was just said. And again, continue to make connections with what you see in the graph and what you see in the table. What do you see in the limit expression? How do they kind of match up? All right, y'all. Now, I'm going to go ahead and take us into the Padlet then so that y'all can put some connections down. So again, this is for today's participation. So please don't sleep on it. You want to make sure that you do it. Otherwise, it gets harder to do stuff when the class is already passed. So again, the Padlet is, let me just move this up. The Padlet is usually again right here at the bottom of the notes section. But I'm going to go ahead and put this back into the chat so that y'all have an opportunity there to give your 2 cents. And you definitely need to give your 2 cents there. We got to see what are you processing. Again, name or initials. Where you're going to go to is going to be on column number 8. So we're on column number 8 on the Padlet. And what I'd like you to think about is what connections can you make with limit notation here, the graph or the table. So what connections are you making right now? And it could be a simple connection. It could be a more deeper connection. Just in general, what connections are you making right now when it comes to graph, limit, table? All right, I'm gonna go ahead and put the directions back into the chat just so that we all know what we're doing right now. Again, we are on column 8. Make sure you put your name or initial for credit. And again, you could click on this to make it bigger, or you could go back on our slide and just take a look at this more deeply. What connections are you making right now? So again, let's imagine you have a table and you don't have a graph and you don't have a limit and you want to make a limit. Just think about what you need. All right, I see a few of you getting started there. I'm going to give some more time so that y'all can process your thoughts. Then we'll come back to it. We'll see what you all are thinking. Again, name or initials. Make sure you get on that Padlet. All right, let's get on there. Let's have one more minute. Let's finish up our thoughts. We are on column number 8 in the Padlet. Again, name or initials. Make sure you add those in. All right, let's go ahead and see what y'all are thinking so far. I know some of you are still writing. Go ahead and finish up your thoughts. All right, so some connections is the table shows undefined at x equals 3. Yeah, for Benny's, there was like an undefined, and that corresponds to the hole in the graph, which is the limit. I like that. So that's true. So, right, if we look at the graph at 3 in the table, it's undefined, and that corresponds to the fact that there's an open circle, but the limit still exists there, and it's going to be at 5. Awesome. And then, okay, we have that someone thinks it's easier to find the limit notation than the table. So the table looks a little bit complex. You could determine the limit and determine if it exists if the table from both sides are the same for the y side. That is deep. Yeah, we might get into that actually in our next class meeting. Yay, we're already kind of thinking ahead there. Awesome. Um, the limit notation is represented clearly in a graph. So for this particular, so some of you are able to see it more clearly in a graph. And both the graph and the table connect because they both have the same numbers. Yeah, you can make the direct connections. But the table shows the exact steps it took to get the final results. And you could use a table to determine if a limit exists by looking at the x and y values from both tables, right? Ooh, the table gives you a more precise number than the graph. And it says in the table, in the graph, you could see it clearly, and in the table, it jumps by the y values. Yeah, I see two of you mention the jumping part, so that's interesting. And then you could see the limit on the graph and if it exists for the table. And then the table looks complex. Don't worry, we're going to get some instruction on how to actually make these tables. So it shouldn't be too scary, I'm hoping. All right, y'all. We're going to go ahead and spend this next portion taking a look at these steps. So we are all on slide number 11, y'all. So again, you can be on your own copy. So these are the steps that I'm talking about. These are adapted from Khan Academy, by the way. Let's go ahead and take these 4 minutes. And then after the 4 minutes, I'm going to take us into our checkout. But let's take these next 4 minutes. That means you want to stay here and read these steps. These are the actual steps. And when we come back to class on tomorrow's Wednesday, right? Yeah, we're going to be meeting tomorrow. When we come back tomorrow, we're going to be doing some group work on making tables with limits. So you'll be in a group. We try to figure it out together, try to work on it together. But before that, I want you to read through these steps for 4 minutes, start annotating, start making yourself some questions, and then we could jump into our checkout. All right, let me know if anyone has questions. I'm going to give you silent 4 minutes to just read through this. So in our last minute, our checkout is going to be to post our wonders right now about these steps. So if you are ready and you still have the Padlet open, it's going to be column number 9. So if you're ready, go ahead and put what you wonder right now. Again, this is like a question, and this is your last part to getting your credit for today. So again, just put in your wonders, your questions about these steps that you're looking at right here, if you're ready. But I'll move us all into that for our checkout in a second. Again, in the same Padlet, column number 9. I'll put the instructions in the chat. I'm going to go ahead and start to put the Padlet there, whoops, in the chat so that we can go ahead and put our notices, wonderings about these steps. Like, if you have questions about them, which you should, because we haven't yet done it, or, maybe you're someone who like, I totally get the steps. That's awesome. Awesome. I see that a few of us are already getting on there. So we're on column number 9. Again, here's the reference of the steps for you on here. But what wonders do you have about these steps? Again, you're going to be going in with your group tomorrow to kind of do this together. But right now, just think about what wonders do you have. All right. We have a few of you getting started there. Let's all get our last comment in so you can get that last piece of credit there for today. Let me know if anyone has questions about, credit or anything like that. Yeah, I'm also hoping I recorded it. I hope, I think it should be recording. Y'all should let me. Yes, it should be if I recorded it. I'll upload the recording. All right, we're on column number 9. We are putting what we wonder. Oh, we got some good questions here. Yep, no problem. These are all super good questions. I can't wait to, we'll open up class answering this. Yes. For our next meeting. All right, everyone, go ahead and finish up. Don't forget to finish up. So if you didn't finish up your last thing, please do so. Otherwise, let's go ahead and enjoy y'all lunchtime. Y'all have a great day. See you tomorrow, everyone. Bye. Enjoy.
All right, see ya.
See ya. Bye.